Now, during the previous videos, we've seen one specific case, but there are more variations around this theme. We have our DGP in blue, given by this expression, and we have the model that we want to estimate, as I've always indicated in red. But we can actually investigate several combinations of our DGP and estimated model. Namely, we could, for instance, add in the drift parameter, also include a constant term in our model, or we have other combinations of deterministic components. Now, these deterministic components do change the limiting distributions, but it's always the same machinery of the Brownian motions that will do the job. We will each time start from our least squares estimate, arrive at our key expression estimator minus true population parameter, and then we determine the factor by which we need to blow up that difference. And to that end, we develop numerator and denominator separately, where the Brownian motion machinery, together with the functional central limit theorem and the continuous mapping theorem, will do the job, as we will always rewrite numerator and denominator in terms of scaled partial sum processes to determine the appropriate scalings. Now, we've considered one case in these videos, and it's only natural to practice with the other cases, as you will also do in the tutorial for case 2. Now, which unit root test should you use in practice? So how do you decide on the deterministic terms that should be included in the model? Well, you should give the alternative a fair chance to describe the data. A constant we would actually always include in our model. But what about a trend? Well, when your series has a clear trend, you should include it in the equations. Since then, there would be no possible way that you could have a stationary series otherwise. If there is a trend, you would like to make the decision on the nature of the trend. So is it a trend or a different stationary process, where the null corresponds to different stationarity and the alternative is trend stationarity? If, on the other hand, you don't put a trend when there should be one, you might falsely conclude that the series is different stationary. So just because the alternative is given no fair chance in describing the data. And that might lead to over-differencing. On the other hand, if you do put a trend, while it's not really necessary, you might lose some power, so you might sacrifice some power, but at least trend stationarity gets a fair chance as an alternative. In practice, we will also typically follow the so-called Pantula principle to determine the order of integration of a series. You typically start by determining the maximum number of times you would have to difference a series in order to have a stationary series. And we will often use Dmax equal to 2. Then you will perform a unit root test on this second difference. As you expect it to be stationary, you expect to reject the null hypothesis of a unit root in your series in second differences. And then you can continue with the first difference. So D equal to 1 in that case. And you can again test for a unit root in that guy. If you do not reject the null that the series in differences has a unit root, then your series is considered to be integrated of order 1, as denoted by I1 in that case, which means that you need to difference it one time in order to get a stationary series. If, on the other hand, you do reject the null again, then the series in differences, if you reject the null again that the series in differences has a unit root, Then you set D equal to 0, and so you do a test for a unit root in the series in levels, namely on YT itself. Now, there are a lot of practical considerations to take into account for unit root testing, how to determine the deterministic components. Maybe there exists alternative automatic procedures to work your way around the inclusion of these deterministic components. Well, start by having a look at this paper with corresponding R package put-UR that Stefan Smekes and I recently wrote. We will actually make use of this package to apply also unit root tests in practice during the upcoming sessions. So please familiarize yourself already with this paper this week. And you will see that we actually make use of also different bootstrap procedures to obtain our p-values. Now, this is not a course on the bootstrap, so we won't dive into those details. And I also don't expect you to study them in the paper. Just focus on the practical aspects and the concerns on the various unit root tests. And that brings me then to the end of this video. You have now everything in place to prepare for your upcoming tutorial. Good luck.